How do scientists survive in Antarctica for months, even an entire year? The environment there is brutally extreme, not just freezing cold, but constant storms from all directions. For half the year, the continent is in complete darkness. Every year, more than a meter of snow piles up, and massive ice shelves drift over a kilometer across the ocean, sometimes cracking without any warning. In conditions like these, traditional buildings simply can't survive. But after generations of innovation and upgrades, modern research stations are now built to handle it. One of the most advanced examples is the Halley VI Research Station. The entire base looks like a futuristic train stretched across the ice. It's about 140 meters long and made up of 8 connected modules. The blue modules are used for living quarters, research labs, and power systems. At the center, there's a red module. This is the social hub, housing the kitchen, dining area, gym, bar, and even media rooms. Each module is mounted on hydraulic legs and skis. This allows the entire station to be lifted above the snow and even relocated if the ice beneath becomes unstable. The modules are connected like a bridge system, sharing power and water, but each one can also function independently. That means even in an emergency, like a fire or structural break, the crew can survive for up to 10 months. But how do they actually live here? Because living in Antarctica means complete isolation. Supplies are extremely difficult to deliver. Icebreaker ships must cut through frozen seas, and aircraft are limited by harsh weather conditions. So, in most cases, the station only receives supplies once a year. That's why one of its most impressive systems is energy. Halley VI uses a system called combined heat and power, designed to extract maximum energy from every drop of fuel. Here's how it works. 2 high-performance diesel engines generate electricity for the station. Normally, engines waste a huge amount of heat, but here, that heat is captured and reused. First, hot water from the engine flows through a heat exchange system, transferring warmth to colder water. Then, even the hot exhaust gases are used in a second stage to heat the water further. This 2-stage process allows the system to recover up to 60% of the wasted heat. The heated water is then stored in buffer tanks, providing warmth for the entire station as well as hot water for daily use. Once cooled, the water cycles back to the engine, creating a closed-loop system. But where does their water come from? The answer is simple: snow. The station collects snow and melts it using heated pipes. After filtration and chlorine treatment, it becomes safe drinking water. Antarctica actually holds about 90% of the world's fresh water, but melting ice requires a huge amount of energy. So conservation is critical. That's why the station uses vacuum toilets, similar to those on airplanes, reducing water usage by up to 90%. All wastewater from sinks and showers is collected, filtered and disinfected, then reused for flushing. Even sewage is treated through biological systems, broken down into sludge, frozen and stored until it can be transported out of Antarctica. Nothing is left behind. The modules are connected with flexible joints that prevent air leaks, resist extreme cold, and handle structural movement. Inside, even the lighting is carefully designed to mimic natural daylight. Because surviving here isn't just about physical needs, it's about mental survival too. Months without sunlight, no outside world, no escape, just silence, isolation, and endless white. And yet, this is where some of the most important scientific discoveries on Earth are made.